Hello guys and welcome back to Angel's Tinkering Corner. So today we have a treat especial. Today we're gonna be taking a look at this package that I got. This is a CNC Arduino UNO CNC board where you can actually use an Arduino UNO to control 4-stepper motors and some other stuff with it. So without further ado, let's get started. So I got this whole package for about $15 and like $2 for shipping. Came from the United States and it's an Arduino UNO shield that is for controlling stepper motors, big and small stepper motors, and also 4 Pololu stepper drivers. To me it's pretty cheap for all that you get. They seem to be quality components, and the company that sells them, I got it from eBay, but the company that sells them is Zyltech, and they even put very good instructions on the boards that they sell, and they also sell some other 3D printed parts. So I think this is gonna be a high quality piece of kit just because of the amount of care that the seller puts into the products that they sell. The instructions of the whole package are pretty detailed. You can go to this website over here, zyltech.com/CNCS, and you'll be able to see all the instructions if you want to buy this or if you don't know where to find it. I would say that the shipping for this was pretty cheap and also was really fast. It came like in 2 days. I wasn't even expecting it to come this fast. So yeah, so what we're gonna be doing is first assembling this board, following the instructions, and also then flash it. And when we flash it, I'm gonna get a power supply and we're gonna test it with a stepper motor that I have here. I got a zip tie here so we can see it moving better, but it's one of the 3D printer stepper motors. I bought this package so I could use it with a CNC machine that I'm designing, but that's for now that's a little top secret, but I can show you guys the electronics that I'm gonna use. I like this package because it's really simple. It's just a CNC controller that you can use with any stepper motors, and also it has ports for end stops and so on. So let's get this open up and we can check out what the package comes with. So got my scissors here. It comes in anti-static packaging, which is good. So this is the main the shield. This is the brains of the operations. I mean, not the brains, the muscle, basically. The pins seem to be really straight, except for a couple of them, like this one. But so far, they're really straight. I'm gonna put this over here. We can open this one up. I'm not sure if this is resealable, but I don't care. To the side. So this comes with 4 Pololu stepper drivers. Comes also with 4 heat sinks to put in the Pololu just in case they don't overheat. And this has a lot of jumpers so you can set your micro stepping. Then here we have an Arduino UNO. Comes with some pins that you can use. Very nice. I don't think I'm gonna use them. I have a lot of them actually. But this is the brains of the operation. This is the muscles. This is the brain. This is the new version of the Arduino UNO that has the little chip that you cannot change. We flip it back. Let's see the soldering. The soldering looks okay. If you see, the headers are a little bit bent to the side, but it's nothing we cannot bend back. There you go. You gotta keep in mind that if you are not completely straight, your board might not fit on top of it. So we can put it right now. Let's see. If it's aligned. It's actually decently aligned. Yeah, there you go. You gotta be really careful when you put these boards on. So that's what it looks. It's really small actually. It's really, the package that it comes in is really small in comparison to, for example, these ramps and so on. So if you need something really small but you don't want to buy ramps, then this might be good for you. It doesn't have as many things as the ramp does. You cannot connect LCDs and so on, but it's really good so far. We have here a lot of connectors that you can put in. You can put in end stops and the minimum and maximum, I think. It has a lot of other stuff. End stops go over here, and there are the 2 pin style end stops. I see some micro stepping pins over here. Here you connect the stepper motor. Here you might put the micro stepping jumpers in the pins. And stops over here. These are directions for the motor. This is where you put the stepper motor controller, and you can put from 12 volts to 36 volts if you want. I'm not sure if you can power it the board directly through it, but I think you can if you power it through 12 volts, or it might be isolated. I'm not sure, but I'm gonna figure it out. So I'll see the orientations in which I have to put this stepper drivers, and I'll be right back. Okay, so I figured out what I have to do. So the instructions say that first of all I have to put in the jumpers for the stepping that I want. In this case, what I want to do is since I have Polulu stepper drivers, the highest resolution that I can achieve is 1/16 steps. So that means the highest resolution, so that means that's as low as I can go. So to achieve 16 steps, what I'm gonna do is I'm gonna put these little jumpers in each of them over here. So in the first one, which is M1, M0, M1, and M2, in each of them. So you gotta put them like such. There is also another thing that I'm gonna be doing, which is the mirroring of the axis. Actually, not the mirroring, but the coupling of the axis, or I don't know what they call it. What that means is that if you want to have 2 stepper motors driving in the same direction, the thing is that you only have one little pin for 1 stepper motor. So if you need 2 stepper motors to drive in the same direction, you cannot do it unless you take this this port over here and you put another driver, and then you actually make the axis go in the same way. So let's say, for example, I want the y-axis to go in the same way, then these 2 y-axes are gonna go the same way. That's about it. Then for the cloning of the axis, I am gonna put 2 and 2 on the y-axis. Where it says y-axis here. So here it says y-axis, and I'm gonna put one here and another one here. There you go. So that means that now these two axes are gonna be going the same way. That's just because of the machine that I'm building, but if not, you can just leave it empty and then you can just deal with it later. If you want to put another axis, you can. So I'm gonna be installing these Polulu drivers. They go oh, what the hell? These are really bent. Holy shit. So that's about it. What I'm gonna be doing now is putting the heat sinks now. The heat sinks are supposed to go on top of the stepper drivers, and what they do is that they help the stepper drivers stay cool because they can get really hot. That is the last one. So this is what it looks like. Pretty nice. I think the only thing that I'm missing to do is put in there the Gerbil controller, so it can move when I give it G code. When I send the G code, it can move. So I'll be right back. I'm gonna go into the computer and I'm gonna show you guys how you can flash it with the Gerbil controller. So I am here in my computer and I have the instructions up. It says the first run, in order to put it properly, you have to check these things, make sure that it's working properly. If you pull your drivers backwards, you might fry them. It says pre-flight checklist. Do a visual check of all the soldering points, plug in the shield of the learning board, and load the Gerbil control of the following steps. Okay. What we're gonna do now is load the Gerbil controller. So this is the source code. It says first to unzip the download you have called Gerbil master. So I have my Gerbil master here. I can extract here, open it, it says Gerbil master. What else does it say? Unzip, launch the Arduino IDE. Please make sure you're using the most recent one. I have it here, I have it installed. Then I'll make this a little bigger. It says load the Gerbil into the Arduino IDE as a library. Click the sketch drop down menu, then navigate to include library and select add a zip library. Touch here, include library, and then select add zip library. So we get this. Luckily I have mine in working folder. Can go in and Gerbil masters. It's supposed to be this one. So Gerbil, we add them. Then it says you find the example that says in Gerbil, that says Gerbil upload. We're gonna open it. gonna open another window and it's gonna show us this. We're gonna compile and upload to the Arduino, connect the Arduino UNO to your computer, make sure the board is set to Arduino UNO, then the serial port. So we're gonna select the board. It's gonna be Arduino UNO. I'm gonna connect my board right now. I'm gonna select my port. I think it's TTY USB 0 because I'm using Linux. If you're using Windows, it's gonna be like COM something. You gotta figure it out. Selected the serial port, then click upload. Make sure it uploads. And we're getting errors. It says permission denied. So I'm back, and what I had to do was run Arduino as root. It's not good to do that, but that's my only choice for now. The process to get it to work properly is too hard. So I'm gonna select my board again, Arduino UNO, port TTY USB 0. I don't think I need anything else. So I'm gonna upload it. It's done uploading now. So now we can open up the serial connection to the Arduino board and check if Gerbil is running. We use Universal G-Code Sender to connect to Gerbil. So I'm gonna run BCNC, which is a program that I got for controlling CNC machines, as root. It's gonna open. I have my port here. I have my baud rate. I have my Gerbil controller. I'm gonna say open, and it's gonna connect. So they say that I need to have the separate motor connected at this point. So that means we can now go and get a power source and also get the separate motor connected and then test it out. So I'll be right back and I'll do that. Okay guys, so I'm back after fiddling a little with it. I got this power supply that I had somewhere around here, and it's 12 volts, 2 amps. These motors are 12 volts, so I can drive them with this power supply. I got the motor connected to the x-axis here, my power supply connected here, making sure that I properly connected, because if you put the voltage in the wrong direction, then you're gonna have some trouble. You might not be able to find your issue after fiddling with it. In this case, this wasn't labeled. This power supply wasn't labeled, which is positive and negative. So I tested it with my multimeter, and sure enough, I got the proper way to connect it. It is connected through the USB through here. The board actually comes with a USB. It's pretty short, but it works well. So here I'm gonna be showing you how this stepper motor moves when I use the Gerbil controller or any other CNC program. In this case, I'm using BCNC on Linux, and I'm gonna show you what happens if I tell it to move 70 millimeters on the x-axis. See, it actually works. It works. I can do really small stepping, like 1 millimeter. Can barely see. Or you can go a little higher, 5 millimeters, and it's pretty neat. I'm sure I'll have to calculate the steps per millimeters, because of the belts that I'm gonna be using and the pulleys and the belts that I'm gonna be using. So I'm gonna have to calculate how much does it move, depending on the belts that I'm using. But so far so good. The motor is pretty cold. I think I'm gonna later on test out to make sure that every of the other axes are working properly. So far I don't see any issues. I still need to calibrate the stepper drivers for this motors, but that's pretty easy to do. You just have to measure the voltage and know what voltage you're supposed to have for a certain motor. In this case it's like 250 millivolts for this stepper motor, but for other motors it might be different. So I think that's about it. Thank you for watching, and I'm gonna have links in the description below where you can get this same board. For the machine that I'm gonna be using, also I need to use end stops and so on. So I'll have to wire some of them and make sure they're actually working. And yeah, that's about it. So thank you for watching, you guys, and thank you always for your support, and have a very good day.